All right, so I think Mariam, you've done really a great thing confirming that you can hear me. Yeah, let me confirm. Want to learn more, but we can't hear you guys. Sorry for that. Please confirm if you can hear me. I've tried to resolve the audio. Just confirm to me if you can be able to hear me. Write in the chat section. I can decide. I can start over now. I can start over. Sorry for that. All right, just guys confirm whether you can hear me now. I think my audio developed a problem and I need to be checking it now and again, and if it has an issue from the other end, kindly let me know if you can hear me. Yeah, we can now. Great. Jasmine, thank you so much. Is this okay for AQ as well? Mostly the physics concepts are quite related, but this is much curated for the GCSE Paper 2 students. I cannot tell you that this is physics is not any different. The concepts are just the same. Yeah. All right, so let's get started. Let's get started from the first part. I was looking at this question and I said this paper is having 100 marks. GCSE Paper 2H is tested 100 marks, and this is 1 hour 45 minutes. And the first question that I was looking at here, before my audio developed that issue, I was saying that if you have a magnet, and then you also have a coil. In the event, let me just, getting a paper so that I can be able to illustrate this on exactly what we are trying to say here. Let me just illustrate this so that I can be able to understand what I'm trying to say at this given point. So we have coils here. Now assume we have these coils here. I have different coils there, and then I have a magnet. I'm inserting a magnet into that coil back and forth. So something that we need to realize is that this magnet has got what we call the magnetic fields. Yeah, so this magnet has the magnetic fields which are pointing from the north to the south like that. So which means when you are inserting the magnet in and out of the coil, the magnetic fields are going to cut through the coil. And when magnetic fields cut through the coil, an EMF, or a potential difference, is induced in the coil through electromagnetic induction. So something that we really need to take from this live today is that whenever a magnetic field cut through the coil, cut through a conductor, an EMF is induced in that particular conductor where the magnetic field is cutting, right? And when that happens, a current flows. So in this question, we are told, explain what will be observed on the on the meter when the magnet is pushed in and out. The meter is going to deflect due to the flow of electric currents. So the meter will deflect, and this deflection is due to the current that is detected. And why is current detected? When the magnetic fields are going to cut, or when the magnet is going to be pushed in and out, these fields here are going to cut through the magnetic fields are going to cut through the conductor or the coil. And when the magnetic fields cut through the coil, an EMF or a potential difference is basically induced in this particular coil, which is going to result to the flow of current. So the EMF is induced through electromagnetic induction. And also you need also to realize that the direction of the current induced depends on the direction in which the magnet is moving. So when the magnet is moving in, the current will flow in a particular direction, and when the magnet is moving out of the coil, the current is going to flow in a particular direction. So basically that's why I need to add a statement here and say that as the direction of the motion of the magnet changes, the direction of the current also is going to change. Yeah, so basically that's what we are supposed to do in this particular question. And I need also to mention, suppose they ask you a question, how can you be able to increase the amount of current induced? To increase the amount of current, there are a few things we're going to do. Number one is using more number of turns, also, or using a stronger magnet, or you can also increase the speed at which you are moving that particular magnet in and out of the coil. Yeah, so basically that's what we're going to do. Then we're going to move to the next question, and this question we're going to talk about transformers. So I need to check in the chat section if there is anything mentioned. Yeah, if somebody left a message there. There is an alternating current of 3 amperes in the primary coil of a transformer, and there is an alternating current of 6 amperes in the secondary coil of a transformer. The transformer is 100% efficient. When you are saying a transformer is 100% efficient, what we mean is the power in the transformer is equals to the power out of the transformer. So which will mean that in the event you have power in the primary coil, then we're going to say is equals to the power in the secondary coil. To the power out. All right, so the size of the potential difference across the secondary coil is, so what happens here, we are going to use the formula current in the primary coil over current in the secondary coil should be equals to voltage in the secondary coil over voltage in the primary coil. Or you can also look at this from power in is equals to power out, from the concept that has been mentioned here, that the transformer is 100% efficient. So which means power in the primary coil is equals to power out of the power in the secondary coil in that case. So of course we can be able to focus now on this first equation that we are given there, and we can say the current in the primary coil is 3 over 6, which is the current in the secondary coil. Now we are trying to find the potential voltage across the secondary coil. So we can be able to say this is VP, so we can be able to rearrange and make voltage in the secondary coil the subject, and you can see voltage in the secondary coil is going to be a half the size of that in the primary coil. So basically that's what we are going to do here, and we can take that to be option that is option it's going to be D. Yeah, so this is going to be D, and that becomes our answer. All right, and the next part, another formula that you really need to remember as far as this area is concerned is voltage primary coil over voltage secondary coil is equals to the number of turns in the primary coil over number of turns the secondary coil. All these formulas, they are provided, so we are not going to cram these formulas in order to answer them. We are told to explain. We are supposed to explain how an alternating current in the primary coil causes an alternating current in the secondary coil. This is a question that is asking you to explain how a transformer works. So the first thing that we need to remember is that a transformer works with alternating current. So which means that for a transformer to work, there must be some magnetic fields which are created. So which means that when current flows through the primary coil, let me just draw a simple illustration. Let me just draw a simple diagram of how a transformer works. And what you need to remember that the main features of a transformer is the primary coil and also the secondary coil, whereby the primary coil is the input and the output is the secondary coil. So that means so that means also we have a soft iron core. So when alternating current flows through the primary coil, we're going to realize that magnetic fields which are constantly changing size and directions are going to be created. So these changing magnetic fields are the ones that are going to cut across the secondary coil. Once there is an alternating current in the secondary coil, yes, this is F. So I thought you said you are going to go over generator and the motor effect yesterday. Yeah, I'm going to go through that. This is electromagnetic induction, and then there are questions. It's on the way. We're going to look at it. F. Mr. F, how are you? Welcome to our live. Welcome, bro. Yeah, we shall look at that area. Yeah. Yeah, so once that happens, then these magnetic fields which are created, when they cut across the secondary coil, this is for Edexcel, yeah, twist, this is for Edexcel, yeah, this is Edexcel 2H, yeah, not AQA, this is not AQA. When the magnetic fields cut through the secondary coil, so what's going to happen is that an induced EMF is going to be created in the secondary coil. So when the created magnetic field, because we have said in the primary coil we're going to have alternating current passing through the primary coil. When that happens, they will create magnetic fields which are constantly changing size and direction. When these magnetic fields cut through the secondary coil, an EMF is induced, an alternating EMF is induced in the secondary coil, which is going to result to a flow of current. Basically, that's what you are going to say as far as this particular question is concerned. Is induced through electromagnetic induction. All right, so I think I need to move this a little bit up so that you can be able to have everything well stated there. So if you are going to meet a question to do with transformers, kindly guys, just crash it, twist. Good luck. 230 volt main supply. The voltage across the secondary coil is 15 volts. The primary coil has 600 turns. We are supposed to find the number of turns in the secondary coil. So we are going to use the formula that is usually given, Vp over Vs, where voltage in the primary coil over voltage in the secondary coil equals to number of turns in the primary coil over number of turns in the secondary coil in that case. So which means if we substitute and we try to make number of turns in the secondary coil, the subject, we can be able to work it out. And if we work it out, our answer becomes 39 turns. 39 turns. Now we have also a generator. Shows a coil of wire that is being rotated within the poles of the magnet. This is the generator Mr. F was talking about. And what is the purpose of the generator? The generator generates electric current. And under which mechanism does it generate current? Is through electromagnetic induction. So what we need to understand as far as this concept is concerned is that when when a conductor cut through a magnetic field, because in this part here we need to appreciate that we have two magnets. We have the north pole and also we have the south pole, and then we have the magnetic fields which are just pointing from the north to the south. Yeah, these fields are pointing from the north to the south. So we need to also appreciate that when the conductor cut through the magnetic field, because this coil is going to rotate within the magnetic field, when it's rotating within the magnetic fields, when it's cutting through the magnetic fields, when that coil is going to rotate within the magnetic fields, it's going to cut through the fields. And when a conductor cuts through the fields, an EMF is going to be induced in that particular conductor. And that is how electricity is generated, because we have a coil that is turning within the magnetic field. As it's turning within these magnetic fields, it's going to cut through the magnetic field. And when a conductor cuts through a magnetic field, an EMF is going to be induced. Okay, so there is no need. Saudi school, 140 mg, there is no need for you to be cooked once you have joined Proflan Live. You are not going to be cooked on this. I'm not going to allow that. All right, so what I'm saying is, when the coil is going to be rotated within the magnetic field, that particular coil is going to cut the field. And when a coil cuts through the fields, then what we're going to have is an induced EMF in the coil, which is going to result in the flow of current. So I'm going to write how you are supposed to structure your answer in this case. So we are going to say, as the coil moves, it cuts through the fields. So as the coil is going to move through the is going to rotate within, it's going to cut through the fields, and the fields of the permanent magnet, that's going to cut through the fields of the permanent magnets, then which will mean that an EMF is going to be induced. Yeah, great. So we agree on that. If you are writing down, you write how a generator works. As the coil moves it cuts through the fields of the permanent magnet, and the voltage is induced in the coil when it cuts through the varying magnetic fields. So the amount of EMF induced depends on Cookie Monster. Hello, how are you? Welcome. The amount of induced EMF depends on the angle at which the conductor is cutting, and also it depends at the rate at which the conductor is moving, and also the position. So when the coil is cutting perpendicularly, maximum EMF is going to be induced. But when the coil is parallel to the field, there will be no induced EMF. So that's why I'm saying the size of induced voltage depends on the rate of change of magnetic field and the angle between the magnetic field as well as the direction of movement. The greatest rate of change is when the coil is moving perpendicularly. Is going to be when it's moving perpendicularly. Cook Monster, this is Edexcel, not AQA. Right. So at this particular point, that's where we have the maximum. Yeah, maximum, and at Q, that's when the object is the coil is moving perpendicular. The field, the motion of the coil is perpendicular to the direction of the field. Yeah, and we are going to say therefore, yeah, the greatest rate of change occurs when the coil is moving perpendicular to the fields, and that is going to happen at point Q and S. At point Q, that is where we are going to have maximum induced EMF, and when the conductor is moving parallel to the field, so the maximum current is at point Q and S. And when the conductor is moving parallel to the fields, then it means Cookie Monster, good luck, see you guys. And then we have, and the currents are moving in opposite direction, so that's why you can see Q is that positive highest point and S is the lowest point, is because the currents are moving in the opposite direction, but that's when we have the maximum. And the next part is to identify no current is induced when the coil is moving parallel to the fields. So that is what I'm saying, that when the coil is moving parallel to the field, and that occurs when the coil is vertical. When the coil is vertical, there will be zero current induced, and that is going to happen at point P, R, and T. So P, R, and T, the coil is vertical. Yeah, so that's when it's vertical, so it will be rotating like that. But when it's horizontal this way, the field will be moving across that way. Then when it will be rotating, the direction of motion of the conductor is going to be perpendicular to the fields which are across. So Q and S, the coil is horizontal. That's when it will be rotating like that. When it reaches the vertical position, the coil will be moving parallel to the direction of the field, and in that case there will be no induced EMF in that case. So this is parallel, this is perpendicular, and then this is perpendicular as well. So basically we need to say this is going to occur at PR and what? T. So the coil is vertical position at these particular points. Now, in the event you are asked to state how you can be able to achieve a higher amount of current induced, something that you need to do there is to increase the strength of the magnet or increase the speed at which the coil is rotated within the magnetic fields. And also we can talk of having more number of coils. That's how you can be able to increase the amount of EMF induced. Question number 10, also in electromagnetic induction, we are told the figure shows a bar magnet that is dropped through a coil, and the coil is connected to a sensitive meter. So you can see we have a magnet at the top, and this magnet has magnetic field. So when it's going to drop, these magnetic fields of this permanent magnet are going to cut through the coil. And when they cut through the coil, an EMF is induced in that coil, which the meter detects. Yeah, so basically that's what we're going to have there. We are saying that this magnet is going to drop, and in the process of dropping, these magnetic fields are going to cut through the coil, and then there will be an EMF induced. So we can put it in words and say, for safety and security purposes, that as the magnet falls through the magnetic field, the fields cut through the coil. Cuts to a coil, and an EMF is inducing an EMF or inducing a voltage, which is going to result to the flow of current, and then that is going to be detected. So the meter is going to detect that amount of current that flows through. So basically that's what we're gonna say in that particular part. And this induced EMF is induced through electromagnetic induction. All right, so we are saying that the magnet falls as the magnet falls through the magnetic fields. As it falls, the magnetic fields cut through the coil, inducing an EMF, inducing a current in the coil, and through electromagnetic induction. Hence, there is a potential difference across the voltmeter, and the voltmeter measures that potential difference, and that's why it shows a reading. Yeah, basically that's what we're going to do. Sometimes you'll be asked to describe an experiment or to show how an investigation can be done, how the student can be able to use this to do an investigation. And the investigation is to find out how the reading on the voltmeter depend on the height from which the magnet is dropped. So in this case, we're going to ensure that the student should drop the magnet from different heights. Upon dropping them from different heights, is going to measure the amount of EMF for each and every height that we're going to have. So in that way, we can be able to compare and analyze how is this going to affect, how does the variation of the height going to affect the amount of EMF, induced. So in this case, the student should drop the magnet from different height, and each height is going to be measured using a meter rule. So whenever you are going to answer a question of this kind of investigation, you need to mention the apparatus that you have used to carry out the investigation. Sorry, I think something was about to power down here. Power down. Guys, can see we have not liked the live. Most of us, we have not liked the live. Guys, just take this chance to leave a comment if you are learning something. Let me get to know if you are learning something from this live. Just write in the comment section. Just write in the comment section, learning something. And also give a like to this live. Yeah, just giving you 2 seconds just to do that. Yeah, just give a like to this live. Write in the chat section, learning something. Yeah, you are learning something. Let me get to know. I'm just trying to check so that I can be able to respond to each and every. Oh, great. Guys have really acted quickly. Yeah, guys, just like, comment in the chat section. Let me get to know whether you are benefiting. Yeah, I'm just doing this for you, bro, guys. Yeah, just leave a comment. I want to read. All right, Declan, thank you so much for your comment, and I wish you the best in the coming exam. Thank you so much, Declan. Great. I'm glad that you are benefiting. So, and the rest, guys, if you are here, please just leave a comment. Motivate me to know that I'm not alone and I'm not talking to myself. You guys, imagine you are just seated somewhere. I'm just seated in my room here, just talking, hoping somebody's listening to me. So it would be a great thing if just let me know that you are benefiting from whatever I'm doing right away. Give a like. Let's proceed without wasting time. I know you guys, you are running against time. I have also to give you value of your time. So in this, to describe the investigation, how it's going to be done. So the student is going to drop the magnet from different heights, and then from there is going to measure the voltage and then record the corresponding voltage induced. Then once that's done, the best thing to do is to plot a graph. You can be able to plot a graph of voltage induced against the height, and then we can be able to comparatively look at what is going to be done. And whenever you are explaining these experiments or investigations, kindly remember to include accuracy. The aspect of accuracy is to repeat the reading for each height to find the average. That is to ensure that the result is going to be accurate. Yeah, so then we shall just plot a graph of voltage against height, so that we can be able to see how voltage depend on height. Yeah, the graph just draw a simple graph. You're not going to include every detail. Just draw the axis. You have voltage in volts and height in meters, and that's all. Yeah, so from there, whoever is going to do the investigation, let him go and do it. We have explained how that investigation has to be done, and you will make the examiner happy by saying that for you to earn your marks. Moving to the next part, moving to the next question. This is about transformers, but it was a quite interesting question because it expected you to draw the transformer. Especially we were talking about a step. This is a step down transformer, because it's the input voltage is 11,000, output is 230. So this is a step down transformer. So which means when you were to explain how it works, and when you were to draw the diagram how it should look like, there are a few features that you had to ensure that you take into consideration. Number one, we shall have more turns in the primary coil. This is the primary coil. And then we shall have fewer turns in the secondary coil. Fewer turns. We have to ensure there are few so that it's a step down transformer. For a step down transformer, we have less turns in the secondary coil. So, and then we have, this is a soft iron core. A soft iron core is used because it's easily magnetized and demagnetized in that case. Yeah. So we are going to say there that further we are going to let's just let me move this a little bit down so that we can be able now to start writing how it works. So a step down transformer or another transformer works with alternating current. All right, this is S. S is saying, sir, we are all gooning in your sexy bald head. All right, this is S100. Okay, fine, thank you S100. Yes, keep gooning in this life, and I believe that you are going to goon that physics on Monday. Yeah, keep gooning. Great, let's revise, guys. So as the alternating current is flowing through the primary coil, it's going to create magnetic fields which are constantly changing size and direction. So these magnetic fields which I created in the primary coil are going to be linked to the secondary coil by the soft iron core, and such that they are going to cut through the secondary coil. When they cut through the secondary coil, we are going to have an induced EMF in the secondary coil. So let's write and say, as the alternating current flows through the primary coil, it creates varying magnetic fields. Yeah, it creates varying magnetic fields. Then when the varying magnetic fields cut through the secondary coil, a varying EMF or potential difference is induced in the secondary coil, which is going to result to the flow of alternating current. Now, since there are fewer turns, since this is a step down transformer and it has fewer turns in the secondary coil, so we're going to say there will be a less number of turns in the secondary coil, so which means that less EMF, there will be less EMF induced in the secondary coil. So I'm just highlighting what you have to write in order for you to earn all the marks, and that is how you should structure your answers. Just understand that when alternating current flows through the primary coil, it creates varying magnetic fields. When these varying magnetic fields cut through the secondary coil, they are going to induce an EMF in the secondary coil. And since we have less turns in the secondary coil, less EMF is going to be induced. Okay, yeah, so and all this induced EMF is through electromagnetic induction in that case. So the question was saying that in your answer you should include the following: detail of the structure of the magnet or the transformer. Number one, it should have coils, that's primary coil and secondary coil. Then it must have the softer iron core. How the transformer works, we have highlighted that. How to design the transformer to enable 230 volts to be obtained. Now in that case, we are going to use the formulas, that is VP over VS, voltage in the primary coil or voltage in the secondary coil, over number of turns the primary coil over number of turns the secondary coil. So that is the formula we're going to use. Yeah, so and then we are going now to substitute, because we were told voltage in the primary coil was 11,000. Number of turns the primary coil, we were told that was what, how many number of turns were here? Let me just check. They were number of turns, let me see. Yeah, we were not given anything, but we are going to give a ratio which is going to enable us write that. Yeah, so these are running halo. This is Edexcel. This is not AQA, bro. This is not AQA. Yeah, this is Edexcel paper 2H. Yeah, so I wish you running halo good luck, and guys, please share this live, like, and also leave a comment. Thank you so much, halo. I wish you all the best in your coming exam. Yeah, Amani, is this combined? No, this not combined. Yeah. Yeah, on this topic of specific heat capacity, that we shall be dealing with specific heat capacity tomorrow, which that's when we shall focus on that specific heat capacity. Today we are focusing more of electromagnetic induction, and then here we are told on the figure, draw the shape of the magnetic fields between two magnets. So we have two poles, like poles. What does that mean? When we have the like poles, we are going to have repulsion. So the magnetic fields are going to repel each other like that. And usually the fields are pointing from the north to the south, right? So that is exactly how the diagram is going to look like. The point we have drawn an X there, it means that's the neutral point. We don't have any magnetic fields experienced at that particular point. So can I jit on you? Go ahead. That is S100. S100, just go ahead. Yes. All right, so and there's another question here, part B. Amani, I'm located in Kenya, and I'm the teacher of maths and physics. I teach maths and physics, pure math. I teach further pure math, FP1, FP2, FP3. I'm teaching pure math, P2, P3, P4 for IGCSE. I also teach most of the students in the UK. There are some students I have in the UK who are taking GCSE physics and GCSE math. So I'm located in Kenya. So much for joining me, bro. And I'm glad you're here. For A levels, we shall be walking the journey together. So just subscribe, remain in Proflan. Once also you are done with your GCSE, for A levels, AS and A levels, we shall walk the journey together. Great. And all the best. Yeah, so in this question, we're told the figure shows a toy that has plastic cylinder, a plastic base of two similar magnets. So we are having a magnet, two magnets, which are placed. One is placed on top of the other, and we can see one is suspended, is just floating like that. We are supposed to answered which question here? Now, the upper magnet seems to float in the above, in the air above the lower magnet. Describe the forces acting on the upper magnet. Guys, can you just write in the comment section? Yes. Guys, can you comment in the chat section? Describe the forces. Which forces are we talking about here? Just write in the comment section here. The forces. Which forces are acting? I would like to know before I move to the next part. A levels. Oh man, you'll do biochemistry, maths, A levels. All right, I'll be helping you maths. Yeah, I'll be helping you maths, so you are in the right place. Guys, can you talk? Can you let me know? Can you describe a little bit which forces are involved here to make this particular magnet above to float? I would like to see who's gonna get it the first time. Actually, this is the first question I've asked in this live, so let me get to know who is attentive, who is keen. Thank you so much, S100, for the compliment. Yeah, so what the forces, this is for higher. Yeah, this is for higher. SCFC 1863, welcome bro. This is higher, GCSE. Yeah, we have a magnetic force. Yeah, there's a magnetic force there. F, correct. What else? Which other force? Which other force? We have magnetic forces. Which other force? Another person? F is, I said it's a magnetic force. Yes, there's a magnetic force. There's another force that we need to mention there. Which other force is it? Yeah, so as F has said, we have, of course, we have the magnetic fields here, right? So these two fields are going to interact. And when the fields interact, because we have north and north facing each other, there is going to be a repulsive force. There will be repulsion. So the magnetic fields of the two magnets interact, and when they interact, then there is a repulsive force, because we know unlike poles attract, like poles repel. Since we are having north and north next to each other, we are going to have repulsion. Yeah, so yeah, you are correct, you are right, I said so, you are right, F, you are right. And I wanted another force. There are two forces acting. Yeah, yes, the two forces that are acting here. Also we have another force. Yes. Yes. And now let me get to know which other force is here. I want to know which other force is here. Which other force? Love you guys, all of you guys. Love you guys. Yeah. I'm enjoying the comments. All right. So the force that is acting here is the weight of the upper magnet. There will be a weight acting downwards. So you need to remember that that magnet that is at the top will be experiencing a gravitational force. So we are going to say that weight acts downward on the upper magnet. So we have two forces, the weight and also the repulsive forces from the magnet. So the two forces are equal. So when the two forces are equal, then we are going to have equilibrium, right? I believe that is okay. The two forces are equal in size. The two forces are equal in size. And if the two forces are equal in size, the weight and the repulsive force, then it will mean that they are going to be balanced, and when they are balanced, the upper magnet is going to float. That's basically what we're going to say in that particular part. Right. Yeah, so let's move to the another area here. We are told the figure shows a current carrying conductor, carrying wire, a current carrying wire between the poles of the magnet. So if you have current flowing through a conductor, and that particular conductor is placed between two magnetic fields, or the conductor is placed within the magnetic field. Let me just use this. If I'm having this conductor here, and between this conductor there are magnetic fields, what is going to happen is that when current flows, usually when current flows through any conductor, if this is a conductor and current is flowing through this conductor, around this conductor there will be magnetic fields, and the magnetic fields of this the magnetic fields, due to the flowing current in this conductor, will interact with the magnetic fields of the permanent magnet that we are having here. When the two fields, the fields of the permanent magnet and the fields of the conductor, when the two fields interact, there is going to be experienced a force. And that's what we call motor effect. I believe you are very, very keen on this area because I'm doing this for you. Right? So when current passes through the conductor, when current passes through any conductor, around this conductor we are going to have magnetic fields due to the flowing current. When these magnetic fields around the conductor due to the flowing current interact with the fields of the permanent magnet that we are having here, then we are going to have the conductor experiencing a force. Yeah, which means that in order to determine the direction in which the force is going to be experienced, we are going to use Fleming's left-hand rule. Fleming's left-hand rule states that if the first finger, second finger, and the thumb are held 90 degrees to each other, mutually at right angles, such that the first finger points to the direction of the fields, this finger points to the direction of the current, then the thumb will predict the direction of motion. IC Moji, hi, welcome to our live. Yeah, we're gonna goon this physics on Monday. We have to goon it. Okay, so using Fleming's and left-hand rule, we are going to describe, because here you can see that we have magnetic fields on these permanent magnets. The magnetic field will be pointing that direction, and the conductor also has magnetic fields because there is a flowing current. Yeah, then which means that the conductor will experience the force, and the force experienced on the conductor will be an upward force. So I want you guys to try on the diagram and try to use Fleming's left-hand rule. Can you tell me, are you getting the force upward? You see the fields are pointing from the north to the south. So place the first finger, the first finger, left hand, place it such that it's pointing from the north to the south. And this finger should be pointing towards you, this other one, because current is pointing towards us. I believe you are looking at the screen. Yeah? If you are looking at the screen, you can be able to try it. Then, if you just hold it such that this second finger is pointing towards you, because according to the current is coming towards us, and the first finger is pointing to the direction of the field, then the thumb, you can see the thumb is pointing up. The thumb is pointing up, which means the motion of the conductor will experience an upward force. Yeah, basically that is it. Yeah, so that is how we are going to identify that question, and that will be an upward force, but the magnet is going to be experiencing normal reaction force. For every action there is equal reaction force, and that's going to be opposite, in opposite direction. That is according to Newton's third law of motion. Yeah. Okay. If a conductor is inside a magnetic field and there is a current passing through that particular conductor, the length of the conductor will determine the amount of force also it will experience. So the formula you'll use is that force experienced by a conductor inside a magnetic field will be the magnetic flux density times the current in the conductor times the length of that particular conductor. So in this case, we are going to use this formula in order to determine the length, because we are given the force, we are given the current, and we are given the magnetic flux density. So we can be able to work it out. Let's identify what we have. Our force is 0.15. Our current, our magnetic flux density is 0.50, and this is the magnetic flux density, this is the current, and this is actually the force. So the current is 2.7. Then we are working out L. Then we can be able to make L the subject of the formula in this case, which will mean that we shall put in our calculator, we shall put this as 0.15 over 0.5 times 2.7, and if you work it out, you are going to get your answer. That is 0.11. Yeah, so that's exactly what we are going to write in order to get that. Yeah, so I believe this is one of the questions that will be asked on Monday. So I believe if you have attended Proflan YouTube channel, you'll be in a position to get that 0.11 meter as the length. So we shall transfer it down here just to make peace with the examiner. Just transfer it down here. You'll make you'll make the examiner happy by writing your answer down here, right? Yeah, so calculating the current in the primary coil, just identify what you are provided. We have worked out these questions, so I'm not going to focus much on that because already I've really tried to explain how a transformer works. The formula is provided in the formula sheet. So identify and actually apply that so that you can be able to get all your marks. So if you're new to Proflan, guys, consider subscribing and also like the live. Leave a comment down below if you are benefiting something. So I wish you the best in your coming exam. So I want us to find current in the primary coil, and by dividing by 230 both sides, this is going to translate to what? This is going to translate to, this is going to translate to, oh, did I make a mistake somewhere? Did I make a mistake somewhere, guys? Let me check. I'm checking the chat section and I can see guys are saying got 0.69, got 0.69, I got 0.11. You guys, let's check what could be the problem in that particular part. What could be the problem? Yeah, I got this. I want us to check, guys. Can you confirm? Yeah, what answer did you get? So will this type of question come up on AQA? Yeah. So let me check that value. If there is any miscalculations, I really need to check why guys are saying that's wrong. maybe there could be a mistake. 0.5 times 2.7. Yeah, I'm getting that. All right, yeah, so that's confirmed. Yeah, we don't want to make any mistake. This is the time we cannot afford to make a mistake. That could have been an international crisis, yeah, that needs a meeting to be held in the UN to resolve that. Yeah, so let's move to the next part, and if we divide by 230 both sides, we are going to get our answer equivalent to we shall get our answer equivalent to what? Let's put it in the calc. This is 131 times 1.75 over 230, and this translates to 0.9967. 0.9967, so which is going to be amperes. So that is what we're gonna get at that given point. Now, as far as this paper is concerned, you need to understand the grid system. We need to understand, yeah, you need to understand, we can write that to correct to 2 decimal places. Yeah, we can write it correct to 2 decimal places. But what will guide us on the number of decimal places? Okay, let me just address this because Izmoji is asking that. Yeah, Izmoji is asking that. Let me be very clear on the number of decimal places that you are expected to round off when you are doing physics. Look at the number of significant figures that are given in the data provided in a question. For instance, if the values given that you are going to use to calculate a given value, then it will mean that you should give them correct to the same number of significant figures as the given values in the question. That is the best guide around that. Yeah. Yes. As 100%, me and you, in 2 days until Monday. Yeah, me and you until you are very comfortable with that paper, and thereafter, I believe you are not going to run away. You will be remaining as a student of Proflan. Yes. All right. Now, electrical generation. Electricity is generated through electromagnetic induction. That's what we have to agree. Because if we are talking about hydropower generation, is whereby water is trapped in a dam, then the gravitational potential energy is used to harnessed, then when that water is released, is going to turn the turbines. In the process, the turbine rotates the generator, and the generator has got magnets, and there is a coil within that generator. As the coil rotates within the magnets, electricity is generated through electromagnetic induction. If we are talking about power generated using coal, heating, water, then steam is generated, and that steam has high pressure to rotate the turbines, and turbine result to the generation of what? Electricity. So that's not what we are focusing in this part. What we are focusing is in the process of electrical generation, there are different features that are going to take place. Number one is that after electricity has been generated in the power plant, what is going to happen is that electricity or voltage has to be stepped up. So in Q, whatever we have in Q is a step up transformer. Then we have R. R is what we have here is the connecting wires made of copper and any other materials. Then which is going to be used to transmit electricity. Then we have, after electricity has been transmitted through the cables, then we have a step down transformer, which is going to enable the voltage to be stepped down to be used in our homes. So in this question, we are supposed to state, using figure 22, explain the stages in the process of delivering electricity efficiency from P to T. Your answer should include the details of the effects of Q, R, and S. We have said Q is the step-up transformer, which is going to increase the voltage. And remember, when voltage is increased, it's going to be transmitted at high voltage so that we minimize power loss. We're going to reduce power loss in that process. We have this power generated. We have a step-up transformer to increase the voltage transmitted, and then step-down transformer is used to reduce the voltage for safety purposes and for usage. Okay, then we are going to write and say, let me just move this. We have to, let me just write the model answer you are supposed to say at this given point. Electricity is generated at point P, and remember, we need a step-up transformer used to step up voltage, so that electricity can be transmitted at high voltage and low current to minimize power loss, at this given point, and low current, and this minimizes or reduces power loss, the process of transmission. In R, then we know that power loss is power loss is I squared R. Then at S, voltage is stepped down in order to be used in the households. So basically those are the steps that you are supposed to state in the process of transmission. Question number 10, we are talking about a dynamo, and a dynamo, of course, is a device. When rotated, it can be able to generate electricity, which is usually so which means that I think we need to focus on the learning and our revision, guys, so that we can be able to ensure that we are benefiting, because I'm very sure most of the guys who are here have come to learn physics, and that's what you should focus on. So a dynamo is used to generate electricity, and this is when it's rotated, a coil cut within the magnetic field. So this is going to be what? Let's see. So the dynamo contains a coil of wire that spins inside a permanent magnet, and when that coil spins, it's going to cut through the magnetic field, and that's why EMF is induced in the coil. The teacher connects a voltmeter to the terminals of the dynamo, isn't it? So which means one of the rotation, look at this, when the teacher was rotating this, I want you to notice, as the teacher was rotating this, what happened? As the teacher was rotating this, there is a current detected, and this current detected Yeah, so this current detected is which magnitude? Let me just show you. This current is around no, it's a voltage. This voltage is around 0.75. Yeah, here is 0.75, and this one is positive 1.25 volts. So which means we are having positive voltage and negative voltage. Why is that the case? It's because the direction of motion or rotation was changed. The teacher rotated in the opposite direction but faster, because initially it was 0.75. now it becomes 1.25 volts. So meaning the teacher might have rotated faster and cutting the magnetic field at a higher rate, resulting to the greater induced EMF. So faster than B, yeah, speed of rotation faster and in opposite direction. Explain why it's more difficult to turn the dynamo when the lamp is connected. Remember, when the lamp is connected, some energy, electrical energy is transferred. So when electrical energy is transferred, then the teacher has to do more rotations in order to replace the used energy. Yeah, so we're going to say electrical energy is being transferred to the lamp, yeah, increasing the load. So more energy is done, and you can see now when this is connected, then it means that more energy is transferred to the lamp to light it, and this increases the load, so the teacher has to do more work. So in that case also we need to add a statement, say this creates an opposing magnetic force. This creates an opposing magnetic force which resists the motion. This creates a greater opposing magnetic force. So the reason as to why it's difficult for the teacher to rotate is because most of the electrical energy that's generated is transferred for the teacher to do what? For the teacher be transferred to continue powering on the lamp. So in that process, that is exactly what we have. Clegg, sir, I'm confused. Clegg, which area are you confused? Let me get to know. Clegg White, where are you confused? Red for life 100. This is GCSE. This is not IGCSE. This is GCSE. If you are taking IGCSE, check in my channel. I have done a prediction on paper 1 and paper 2. Red for life 100. Check in my channel. I've done already. I've done a prediction of GCSE paper 1 and paper 2. So for paper 2, this is not for you. Red for 100, for life 100. And Clegg White, kindly make sure you let me know where you are confused, so that I can be able to help you out. Yeah. All right, so moving to the next part about transformer. Already this one we've worked it out. You need to use the formula. This one I'm not going to explain, because from as we started our life already, I've already talked about more of this on how you're supposed to work out missing values of current and voltage. Yeah, so this becomes 5.175 volts. Now the next part that we're going to look at is how a loudspeaker works. This was for F. F requested yesterday, can we talk about how a loudspeaker works and how a microphone works? So in this case, we have a device that is simplified. So a loudspeaker is a device which can be able to produce sound. And a microphone is a device that converts sound into a signal and it's transmitted. Let me start by talking about a loudspeaker. There are main parts in a loudspeaker. Number one is a permanent magnet. Can you see it there? We have the north, south, and north. That is the permanent magnet. And the purpose of this permanent magnet is to ensure that there are magnetic fields. The second most important component of a loudspeaker is a coil. That coil is wound here. Now the coil is attached to a movable paper cone. This paper cone can be able to move if the coil is moving. So when alternating current flows through the coil, magnetic fields are created due to the flow of current. These magnetic fields are going to interact with the magnetic fields of the permanent magnet. And since these are two magnets interacting, there will be a pull and push force created. And in that process, the coil is going to experience a vibrational force. That vibrating mode of the coil is going to make the paper cone to vibrate, thus producing sound. That's how a loudspeaker works. Let me repeat. When alternating current flows through the coil, it creates magnetic fields which are constantly changing size and direction. Those magnetic fields interact with the fields of the permanent magnet, hence producing a force through motor effect, making the paper cone to vibrate, thus producing sound. Dopamine Duo, how are you? Welcome. I would have loved to read that message. Yeah, maybe check your internet, Clay White. Yeah, let me get to know if there's anybody who's undergoing that, but I believe from my side everything's well set. Yeah, I can be able to see from my side everything's well set here. Yeah, Clay, check your connection. Yeah, so I've explained how a loudspeaker works. Now a microphone. For a microphone like this one, this microphone, you see when I speak, it will pick my sound. My sound will be transferred to the microphone, and the microphone inside it has a paper cone, which if I speak, the paper cone will vibrate. When the paper cone vibrates, it will make the coil that is inside there to vibrate. As that coil is vibrating, it will made it to vibrate, or it's made to cut the magnetic fields. I don't know whether you're getting me. I speak like this, the way I'm speaking this way. The paper cone that is inside here, inside this microphone, the paper cone inside this microphone is going to vibrate, making the coil also to vibrate. And when a coil or a conductor move within a magnetic field, a voltage is induced. A signal is generated, which is transmitted through the cables, and that sound is going to be detected. So without much ado, let me just write what you are expected to write in an exam setup in order for you to earn all the marks. For you to earn all the marks, how you are supposed to structure your answers in order for you to earn. All right, Craig, I'm glad it's okay now. I'm glad. That's great. Yeah, I believe now you can be able to see our loudspeaker. So we're going to say as the loudspeaker when alternating current flows, it creates magnetic fields which constantly change size and direction. the created magnetic fields interact with the fields of the permanent magnet, making the coil to experience a force, and the force is varying, in size and direction, so due to motor effect, making the paper cone to vibrate, hence producing the sound. So that is how you are going to structure your answer when it comes to how a loudspeaker works. And then for a microphone, so when the user speaks, oscillating magnetic fields are created or are set up, generating an alternating potential difference which result to a flow of signal. So the field to cut the coil, then an alternating current is going to flow. So basically that's what we are going to say at that particular bit. And up to this particular point, up to this hour, I can say that we have come to the end of our lives, guys. We've come to the end of our life today, and tomorrow we shall be focusing on other more important areas you must know before Monday. We shall be looking at what you should focus a night before the exam. So you can see one of the questions that we are going to look at is area to do with specific heat capacity, and we shall be able to add every area that is technical, and we shall focus on how you are supposed, which are the main tips you should know as far as the tomorrow exam is concerned. So tomorrow also we shall be looking at the required practicals that you really need to know as far as this exam is concerned. So I believe, guys, you have benefited from this particular live that we have done today. And if you have gotten value from this live that we have done, I would like you guys to leave a comment and let me know that you have benefited. So for those who are joining us, I'd shared the link that is going to take you straight to the paper. I pinned that message up somewhere here so that you can be able to download. You can be able to download that paper and then continue working on it. So go ahead, download the paper so that by the time you are coming tomorrow already you've done some of the question. Maybe you are just coming to check which areas that you struggled. At that particular point, I would like us to end our live there, and I wish you all the best. Continue revising, and then see you tomorrow. See you tomorrow, guys. Thank you so much, Clegg White, for your feedback. I would like to hear from the rest of our friends who are here. I can see we are 9 of us. Yeah, so just write in the comment section if this live was beneficial, and let me get to know if there is any topic that you feel that tomorrow I should also add in the live. Just like the live before you leave, and write in the chat section if there is any topic you feel that I need to go through it tomorrow so that you can be able to benefit. Clegg White, you are most welcome. I'm glad you got help. Bye guys. Let's write in the chat section bye. I can see Fire Legend 138. Does this affect Tesco opening times? Legend, see you tomorrow. 138. Legend, fire legend, see you tomorrow, bro. Yeah, wish you the best. See you tomorrow, guys. Same time, same place. Same time, same place tomorrow. See you.